We'll now start looking at some properties of exponents. And in order to talk about the properties of exponents, we have to really understand exactly what an exponent is. We talked about how multiplication is essentially a repeated addition of the same number over and over, and an exponent is going to be a repeated multiplication. So something like a to the n means multiply a by itself n times. As some examples, 3 to the 5th means 3 times 3 times 3 times 3 times 3. I multiplied 3 by itself 5 times. For 7 to the 4th, I need to multiply 7 by itself 4 times. 7 times 7 times 7 times 7. What about 6 to the 1st? This means I just have one 6 on the right-hand side, so 6 to the 1st is just 6. In general, anything to the first power is just itself. So now we know what all of these positive numbers mean, or at least the positive integers, but what about 0? Can I have an exponent of 0? In order to figure this out, we're going to see if we can pick up a pattern. Math is really all about the patterns as long as you know how to properly pick them up. 2 to the 4th, that's 2 times 2, which is 4, times 2 is 8, times 2 is 16. 2 times 2 times 2 is 8. 2 times 2 is 4. 2 times nothing, just 1 2, is just 2. So what about 2 to the 0? We can see to get from 16 to 8, we need to divide by 2. 8 to 4, we also divide by 2. And to get from 4 to 2, we divide by 2. So in order for our rules of exponents to make sense, we need to continue this pattern. So here, we'll divide by 2. And 2 divided by 2 is 1. And in general, this is going to hold no matter what your base is. Anything to the 0 power will be equal to 1, with only one exception. 0 to the 0 power. What is that? And the answer is, it's a little bit more complicated. And if you make it up to calculus, you'll look into this a little bit more. But for now, we're just going to realize that we don't really know. We'll now start to consider some of the properties of these exponents, and we'll do these using basic examples. Let's think of 4 squared times 4 cubed. 4 squared means 4 times 4. 4 cubed means 4 times 4 times 4. In here you can see what we're really doing is multiplying 4 by itself 5 times. So this is the same as 4 to the 5th. Another example, 8 to the 4th times 8 cubed. Well, 8 to the 4th means I have 4 eighths, and 8 cubed means I have 3 eighths. So total, we can count and see that we have 7 eighths. So this is the same thing as 8 to the 7. In general, a to the n times a to the m is equal to a to the n plus m. We can just add the exponents. For our first example here, 2 plus 3 gave us the 5 that we needed. In our second example, 4 plus 3 gave us the 7 that we needed. It is important to realize that in order to use this, both of our bases have to be the same, but as long as they're the same, a multiplication is just the same thing as adding the exponents. But what about division? Division naturally goes along with multiplication, so do we have a nice exponent property for that? Let's consider something like 7 to the 5th over 7 cubed. The top of this needs to have 5 7s, all multiplied together, while the bottom has 3. And now we know that things in a fraction can cancel. I have a 7 that'll cancel, another 7 that'll cancel, and then a third 7 that'll cancel on both the top and the bottom. Therefore, all I'm left with is 2 on the top, so 7 squared. Let's look at another example. For something like 5 to the 8th over 5 to the 4th, the top has 8 fives, and the bottom will have 4 5s. We can then start canceling. As long as we cancel the same thing on the top and the bottom, we're fine. And then you notice when we do that, we're left with 4 5s. So this is 5 to the 4th. In general, a to the m over a to the n is a to the m minus n. When we're dividing, we subtract exponents. So this gives us now our property for multiplication and division. But there is one kind of issue that we haven't addressed yet. Something like 6 to the 4th over 6 to the 7th, if we try to subtract these exponents, like our property says, I have 4 minus 7, which is 6 to the negative 3. But the question is, what does this mean? We know what 6 cubed means, and we talked about how this works for positive integers and for 0, but we haven't said anything about negative exponents. Is this possible? And the answer is yes. Let's take a look at this from the other method we were using to actually find this quotient rule. I should have 4 6s on the top and 7 on the bottom. When we start canceling things on the top and the bottom, you'll notice that everything on the top cancels. Essentially, the top turns into a 1, and the bottom, I have 3 6s, so 6 cubed. And in order for things to make sense mathematically, we need 6 to the negative 3 to be the same thing as 1 over 6 cubed. And so this is how we define negative exponents. A to the negative n is the same thing as 1 over a to the n, just like 6 to the negative 3 was the same as 1 over 6 cubed. In addition, if I have a negative on the bottom of a fraction, it moves to the top. Essentially, all a negative exponent tells you is to move that term to the other side of our fraction. The last property we'll consider here is raising a power to a power, 5 cubed to the 4th. We know that what this means is we're going to multiply 5 cubed by itself 4 times because that's what that exponent of a 4 means. And then our property of multiplying these things says now I need to add. 3 plus 3 plus 3 plus 3 is 12. What about another example? Here I have 2 to the 7th to the 3rd power, so we multiply it by itself 3 times. 7 plus 7 plus 7 is 21. And in general, if we want to raise a power to a power, it's the same thing as multiplying. And you'll notice this sticks true at the top too. 3 times 4 is 12, and 7 times 3 is 21.